So welcome to the April 14th Zoom of the food-related process ontology group. And this morning, I've managed to get a few things done promised from last month, and Tarini as well. So the agenda on the call group document I've dropped in the corner there, and on the agenda, unresolved items, comments from last call, EXACT and PO2 mini model discussion, and pureed carrots example. So first, does anyone have another item that they'd like to add to the agenda? If not, if we have time, can always cover other things at the end. Okay, so I will screen share, and we'll go over some questions and changes made to the process diagram. As soon as I get draw IO. Okay. I'll just hopefully present this at a size that you folks find comfortable. Oops. So just as a broad overview, the diagram has slowly undergone a few changes, and including kind of sectioning different parts to talk about. The changes that I've personally made in the last month are up in this corner. So I finished last night a little comparison model of the EXACT2 process model, just to know kind of an overview, and then a PO2 process model, so could get to talking about that. Actually, I just remembered on the agenda, the first thing I wanted to talk about was unresolved items, comments from last call. And so Magali, you had mentioned a question or two, and I just wanted to touch on those. So I guess the first one, I was just curious, separation. We're trying to look at different kinds of processes that involve separation. And you mentioned an electric charge separation, and that sounds like something you know about. What is that about?
Sorry, it was not. I added that because of the physical properties, but it is not by phase.
Oh, okay. Okay.
Sorry for that.
But
it was just a suggestion, but I added that without seeing the title.
Okay, but I am curious. Is there electric? I am curious. Is there some kind of electric charge separation process that shows up in the food industry?
For example, membrane ionic exchange, or membrane. Okay. I don't know the exact term. Membrane exchanging, ion exchange.
Okay, all right. I'll just pop that up there. And then you also mentioned, you consider also freezing and freeze drying as physical processes. And indeed, that's important. So we'll try to see how they could fit in. So I'll just pop those in.
Okay.
Okay. So, all right. So back to the diagrams. So I've added EXACT2 and PO2. So let's see, who do we have on the call? I see Eliana Ivanescu, but probably, and Larissa. Okay, excellent.
And Magali can answer also. So we are both for PO2.
Okay, okay, and Magali. Okay, great. So Larissa, you can correct me if I'm wrong. I took a look
No, you're absolutely correct. And there are reasons why it was modeled like that. And I don't think these reasons applied for your discussions. So if you're curious, just background, because it was for robotic equipment and there are just different mechanisms to capture it. So this ontology was used in addition to some more programming approach where all these changes, so there were preconditions before each action and post-condition if they're met or not.
Mm-hmm.
So it was deliberate separation, but for what you are discussing here, yeah, it needs some solution that it's in one place.
Yeah, well, I recognize that we may end up with a slightly different set of relationships and data structures, but this idea that a experimental action, which is a process, and when you look at the list of experimental actions you have, they all look like they're right out of cooking school. So I really think there's a strong overlap, and in food science, when things get really technical, it seems to me food preparation of formulations really looks like a laboratory process. So
no, I agree with you. So we deliberately made it as simple as possible, so it's easy to combine with other software that used in some cases. So it worked in that setting. So don't claim that this is a solution for, so especially if we are talking about some more generic ontology describing process, it's a very important aspect. Yeah, let's see what options are, how it can be reflected.
Right. And I was after just looking at the parallels. So experimental action is a kind of process. In your case, you were sort of abbreviating attached qualities. So experimental actions had qualities such as temperature. This looked like a way of just keeping track of either what a constant was or what a variable was that the experimental action affected. The participants were often biochemical entities. If they weren't that, then they were calculations of some kind on information, but most of the time it was a biochemical entity that was acting as a participant. You were avoiding the has input and output of material entities. And so that's a difference that's happening here in the OB process model. This participant is changed as a result of the experimental action, but the before and after states can't be described because it's just listed as a participant without that IO distinction. Just like the OB paradigm, where a process has a performer, which could include agents and devices and so on, you had a participant of equipment. And then also this participant of data entity, that is kind of like the other option. If it's not a biochemical entity that's at work, then it's a data entity. So that matches over to the fact that processes can have data as input and output in OB land. So the other thing that's not really covered in the OB world is that experimental actions can have conditions, whether optional or required tests that invoke them, I presume. And in OB, in processes, there never really wasn't set up any kind of a conditional separate has proposition relationship to a conditional that the process would be invoked on. I think it was left basically to the characteristics of the input to be looked at as kind of requirements for whether the process could have such a thing as an input and get rolling, basically. So there would be, we would have to experiment more with how to express the conditions under which a process is invoked. And the has proposition goal of experimental action, well, that is very much like the plan specification, which includes goals and protocols in OB land. I guess I should include a little reference off to a diagram that I did around all of the guts, the bits and pieces of the plan specification, which still doesn't break things down in terms of steps like PO2 does, but so there's more space to cover there too. So that's the takeaway I got from taking a look at EXACT2. The fact that there's some, although there's a fair bit of mapping, there's portions that our process model would need to develop to match it. One other thing I saw is that in this, when you put it together, you weren't using OWL cardinality to enable things to be optional or not. But I believe in OWL that there's that ability to say some action or process has min0 and then some component, and that enables you to say whether it's optional or not. So we would probably take advantage of that if there were conditional parts in a process. And your durations, you have a period or duration or for any particular action within a larger experiment. And there is that same duration thing present in BF or OBO Foundry land, which is a PO2 thing. PO2's phenotypic ontology kind of danced around concepts of time, but they have a duration time. But nobody, believe it or not, in OBO Foundry has a start time and an end time defined yet. And so people have been turning to external time ontology to express moments in time or small durations in time. Okay. Anything more to say, Larissa, on that? From what my...
No, your analysis is very accurate, and yes, I immediately see how you can change process model in EXACT to have a better fit to OBO, OB models. So I don't see big differences either.
Mm-hmm. Okay.
Sorry, just a question, Magali.
Yeah.
I don't really understand what the meaning of the relation as proposition is. What is the meaning of this as proposition relation?
It is when a class is connected to some information entity, basically. So it's propositional entity, like information about this action. So this distinction between input, output, participants, and what information is required for it. So the whole model was designed around capturing information that is essential for reproducing actions. And this distinction, optional, not optional, it's because a lot of information is useful, but it's not essential for reproduction of it. So it
Okay,
just
thank you. Thank you.
Basically has
information.
like has information.
And there's a good paper on it, EXACT2 Semantics of Biomedical Protocols. I can drop the link actually into the diagram there, but it goes into and includes some nice diagrams on the information that's being gathered. And
That's
then a
okay.
section on Petri dishes, Petri nets. I'll pop that in there. Okay, so moving over to the PO2 process model. This is also a 20,000 foot view that I was putting together, and I was basing it on half taking a look at this semantic sensor network. And PO2 is based significantly on this chunk of it right here. Everything centering around observation and the sensors that carry out an observation and the results and the time at which that observation took place and the things that were being looked at in a more abstract semantic sense. So hopefully this has reflected that. And as well, I was looking at a PO2 diagram. Let's see if I can bring it up into this window. So the same structures for observation, feature of interest, the kind of pieces that are being added on are transformation process of some material, the steps that enable input and output components, material entities, and then the sampler that's, I guess, presenting or isolating chunks of the material input for examination as features of interest in this that the sensor is looking at. And because this particular observation process has specific outputs, it's an observation process that's carried on looking at, say, an assembly line, a food processing assembly line with its components along the way, and is outputting an observation of that transformation process. So related tightly to the same features of interest that the transformation process is generating. And then we get over into exactly how the result is measured or constructed. So it's kind of a parallel thing. You've got the sampling process going on, looking at that transformation process happening on an assembly line in its steps. And to describe the sampling, you're looking at time that had happened, a procedure that was used, and the machine that was used to do the sampling, if I'm not mistaken. And then over on the same side, on the observation side, there's a sensor that's looking at that sample, feature of interest, and it's happening at a certain time, and it's using a certain procedure. And the output of that observation is a result. So I would venture that really this is like two separate diagrams joined and showing the similarities of the elements. And the reason why there's such a parallel in the two diagrams is because they're both looking at the same thing on the assembly line. And is that an accurate kind of representation?
Yes, I think it's good. It's very good. I just can add that we arrived at this kind of representation because we needed to represent observation about the process, the step, in fact. And also we needed to represent observation about what we call component, which is the input or the output of the process. So this is the reason we arrived at this, this kind of representation. At that time, we didn't knew that your model or the other model, the EXACT2 model that you present here. So it's
yeah,
it's built from scratch, let's say.
Yeah, you bet, you bet. And there wasn't a whole lot that Obi was exposing. There were a few papers here and there, but I'm totally understanding historically exactly why we are here at this historical moment, comparing different schemes. So, and what I'm seeking to learn is in the PO2 model about how we would represent the same thing with, in my case, with obofoundry relation ontology style relations. So the challenge, your system is like a challenge. It's a gauntlet thrown down. Can we mirror the same thing with these obo relations between entities? And I think we probably can. And so I've been, I'll just say one little thing, which is I've been carrying on a dialogue with Chris Mungal, who did the relations ontology. And basically what's going on is a comparison of a system that uses very general relations, and then a lot more bits and pieces like roles to distinguish what the elements are that are at work surrounding a process. So it means that you have to have a lot more little parts to describe the same thing as a system that makes more use of these object properties that are named more specifically and connect more specific processes. So the challenge is for us actually to explain PO2 in this model without making it too complicated or visually complicated. So that's...
So, sorry, Daniel, if I understand correctly, you mean that you will try or challenge to specialize the as-role relation with some other relation,
right.
For example, our made by sampler object property.
Yeah, yeah.
It was, in other words, made by sampler.
Yeah,
or
just
not?
questioning. Right. If this is a sampling process and the sampler is the machine, the device that produced the sample,
Yes.
or had a role, then we would map this over to a sampling is a process that has a performer, the sampler, and then the role of that performer is the device or the sampling device, if you want to define a sampling device role.
Yes, the result is a sample.
The result
and the action is a sampling.
Right. The action is, or the action or process. I think action and process are synonymous. And then the output is a sample, indeed.
Yes, I agree.
Mm-hmm. Okay. And so Trini and I cooked up a quick example that's starting to make use of the thought here, but I don't know. Trini, do you want to launch into that, or do you want to just oh, okay. First of all, any more questions about these little mini models? We can tweak them and add some referential links to them as time goes by, but they're there to see if we're covering the bases with the work in this model.
Will it if to remodel quickly, like EXACT2, when they put together with Oba Foundry, just very quickly can rename relations to align more closely, because that are simple operations.
Mm-hmm.
So if it's of help, I don't know, just asking.
Yeah, so I was looking at that, and so it's the relations. We have to come up. EXACT2 needs to standardize and obofounderify all of the identifiers of the terms in your ontology. Your identifiers are kind of all over the place right now. So we would have to do one pass on that, and then one pass on the relations. And I guess I could share. Let's just take a quick look. I have it open right now. So there's PO2, and just a sec. The EXACT2. Now I'm going to screen share. Okay, so crash course for everybody in EXACT2. So we have fairly organized underneath BFO and Oba Foundry. We've got information content entity and process. And the juicy bits under process are experimental action, procedure, and protocol. So experimental protocol and procedure, operating procedure, preparation procedure. And those are not needing, they're needing a name, and I think probably a bit of free text in the real world describing what's going on there. No further structure. Experimental action is where all the action is, and all of these processes are easily applicable to food, and they, as well as other laboratory things, and they all show at work these relations, the participants, the equipment, the inputs that are being manipulated, and the kinds of things that can be measured or controlled in the action. So here the has quality, some volume. Something like this would have to change, because in Oba Foundry land, processes can't have qualities. Well, they can have qualities, but they can. Actually, you can talk about a process being fast or slow, but really this quality is of the output material that is, or the container involved. So we would start distinguishing inputs and outputs and devices separately. So there's a transform to happen to further clarify. So has participant in Oba Foundry world has subparts, and some of those are inputs and outputs, and then people, I think, actors, I forget what that one's called, performer, I think. Yeah. So a variety of changes required. And if you take a look at the identifiers in that, this naturally, your own ontology standing on its own development has just sort of the generic ontologies.com, but we would have to look at changing these to a format, and just I can help with that kind of thing, creating a versioned thing and instructions on how to change the IDs.
That would be wonderful.
Something
I wanted to do for a long time, but yeah,
okay.
It's finally can be done.
And indeed, I want every single one of these experimental actions. So the question, though, is if we're going to do all that work to transform, Larissa, should we just pool that work into this new effort to create these things? Or do we create a separate generic
I
process
think it should
ontology?
be, yes, I think it should be separate, generic, it's a cleaner approach. But I think you now analyzing all these sources just have a better sense what would be more practical approach. So personally, I will follow your advice fully.
Right. So then the question is, which processes will food on then specialize in, and which will be a generic process ontology ones? And I think it makes sense to have a generic one with all of these IDs. Okay, so then I think we could table that for a later discussion, but it will be who wants to be involved in the creation of this generic process ontology, which is submitted to Obo Foundry. So let's formalize that later, but let's still work on design questions now. Any other comments about that, though?
I just have a quick comment that I'm so happy that we're finally discussing what process is before we move on to how to classify the processes. I just wanted to say that maybe having a couple of patterns in there as starting points for the generic ontology, that might be beneficial for the larger communities as well, so they can reuse our patterns. So I'm really looking forward to working on those.
Great. And
actually, Damien, I'd like to see the next part first, but I do have a few slides that I put together.
Oh, great.
About process and relative time.
Okay.
So I don't know if you want to go through your what you've done with Trini first, and then we'll circle back.
Yeah, let's do that. And so I don't think it'll take too long. Trini, do you want to lead on the
No,
curate?
no, keep going. And if there's any questions, then I can answer them. But yeah, just.
Okay, so this is EXACT2, and you'll see if you scroll through it, there are other chunks, including the information section and the temperature, some example speed, temperature, volume variables. And just a note, if you're looking to see in Protégé, you're looking at a particular ontology to see where these things are being used, that's the usage tab. So for any term, go over to the usage tab to see exactly where that thing is being used. So then you can zip over to ramp and see has quality some speed, has quality some temperature. Okay, so I will close up the crash course in EXACT2.
Sorry, Damien, just one question, more additional question. I don't understand why you say that a process can or cannot a process have some qualities.
Right. I was forgetting that in Obo Foundry, there was a bit of an attempt to say processes can have qualities too. And so I think in my head, that translates to the rate at which a process can be applied. Work can be quickly done or slowly done. We have those kind of descriptors in our language. But otherwise, really, the qualities are changes, phenotypic changes to the material entities or the information that's being input or output.
Yes, we are using the sensor properties, the SSN property for that kind of thing, for quality.
Yeah, so for me, it's a process of seeing in these other ontologies what their terms map over in terms of information quality or characteristic. By the way, the whole Obo Foundry world is trying to move towards the word characteristic rather than quality.
Yes.
Which I think probably fits better with the food science world? Because I've heard quality means something very specific in food science.
Yes, I agree.
Okay, so I will try to train myself to use the word characteristic more. Okay.
We will train ourselves too.
Okay. So in the interest of moving this along so we can have time for Robert's talk, how about I not dive into what PO2 looks like under the hood in terms of OWL? Maybe, in fact, I allow it, in the future Liliana or Magali to give us a tour in OWL in Protégé, but or I can, but maybe we'll save that for a month from now. And then just go and take a look at the pureeing example, and then we'll be on to your stuff more. So, share screen. Okay, so carrot puree example. Very pretty simple example, but it starts to get at where we're going to try to find some logical benefits of doing all of this with respect to OWL. The idea is we're going to start with carrots and we're going to end up with pureed strained carrots. And so boiling is a process that has input carrot. We didn't show a role for the carrot. Boiling can have other inputs like energy and participants like the device that the boiling is happening in. So this is a simplified diagram that could be expanded a lot more. It's just going to show, it's just going to focus on the phenotypic changes that are happening in the materials that are involved. So the output is the boiled carrot, and there is a guaranteed quality that it's soft and hot as an immediate effect of that boiling process. By having pureeing stuck right on there, we're implying that whatever's being pureed is hot and soft. Nothing has changed. So in fact, there might have been a cooling process in the middle, but we've skipped that. Pureeing has a performer blender in the ROOB parlance. And here we're introducing a role, a device role, which would be one of in a hierarchy of roles that is realized in the pureeing process. So where there may be many performers, we're individuating that this device is a device rather than, say, a person or some other actor. The output is pureed carrot, and this is guaranteed to have a quality viscous. Now, viscous is a PO2 ontology phenotype, and so it applies to a material entity. This whole diagram is not at the class level, it's sort of at the instance level. So pureeing can puree all sorts of things, but here's an instance of pureed carrots. It has this viscous quality. If this was a diagram at the class level, then I wouldn't have said a pureed carrot. I would have said pureed food is guaranteed to have the viscous quality, but it's the carrot that we're talking about in particular. So there's a straining process, and that finally outputs pureed strained carrots. And they are guaranteed to have a smooth quality. And one of the logical inferential objectives is to say that we can infer that pureed strained carrot must be a solid food for infants without explicitly having to say it is, because all solid food for infants have quality viscous and smooth. So this is my job for a month from now to see if I can make that inference happen in a way that still provides a nice definition for what food for infants is, that doesn't accidentally mix other kinds of foods in there by inference. You're seeing the application of a waste role here to distinguish that in the straining process, we're going to get some insoluble carrot fiber out of it. And that output, so there may be many outputs of straining or pureeing or boiling process. And the logician's grammar is to distinguish these outputs and their relations by these rules. Now, what a refinement, what moving away from general object properties into specific object properties does is allow you to shorthand and not state the role at work. Instead, you have relations like has, waste. But if that relation exists on its own, it is semantically opaque. You don't know that the waste role, if there are semantics around what this is, you don't know that this relation has that semantic hidden in it. So in a sense, the promise of having more of a generic object property approach is that there can be put more semantics into the different parts of that representation and therefore get more of a logical consequence out of it. But that's just a promise ontologists are making. And you only see that when people actually get around to using reasoners, and on giant triple store databases, that's just isn't practical. So it's this delicate balance of trying to run examples like this through OWL and see that they reason to something, and that maybe that can act as a gatekeeper of data going in and out of a much bigger database that itself cannot be reasoned through. And that's the end of my little speech. Karini, do you want to add more to that?
Yeah, it's all good. Of course, all these processes, boiling, pureeing, straining, are in the need to be added or in the process ontology and need to be organized appropriately. So you're not seeing that here, but yeah, that's a task to do.
Right. I had initially put this morning that pureeing was a form of fractionation, but we have to discuss that, slowly figure out that kind of a case example.
Yeah, seeing it in this form also helps to, again, look at the hierarchy with kind of fresh eyes and organize the classes there better. So it's a good complementary process.
And just to say, maybe we're premature in calling this a waste role. There might be some good use for boiled water.
Yeah, no, absolutely. And the same for the insoluble carrot fiber. I think that's like, like whey is a good example of that as well, where, I mean, especially if you're like an industry, then you have to also invest money and develop an alternate use for this. So sometimes in the short term, you end up throwing this away. And the problem with the boiled water is often a lot of nutrients have leached out into it. So that's just that. For me anyway, that idea of waste is basically showing unused potential.
And sideways, if this boiled water is hot, you might be able to extract heat from it in order to do the next cycle of the industrial process. So there are all sorts of other possible wonderful discoveries hidden in the appropriate semantic modeling of all of this. Okay, so with that said, any other comments about this? What do you guys think?
Can I have a question? I think it looks fantastic. It's very clear. Also, you can see how we can remodel everything, what we have in our lab, just following it. My question is, if you have this generic model describing processes, input, output, roles, I assume that you can go to instance level where you have instances of each actions, and because in many cases you need to link this concrete pureed strain carrot to initial carrot.
Yeah.
So to infer that it was from that bunch of carrots.
Yeah. So instance level, I would call this instance level because it's mentioning specific names here. I'm totally with you in terms of annotating all of the detail that happens in a laboratory or industrial process with temperatures and all of that. We haven't added that level of detail here, but it would probably be as big. This diagram, fully spelled out, would probably be as big as this diagram, perhaps. But it's back to that thing about patterns. Let's establish the little patterns, the nano publications for the data bits and pieces, and then they would come together in a bigger RDF graph representation of any process rollout. Yeah, I'm avoiding, you don't see any, my legend is always blue for process, pink for role, green for material entity, and gray for information. And there's no information present here, but there could well be measurements of the temperature, measurements of the viscosity, and so on.
And sorry, Damien, what about primary objective role? You mean that you want to show the sequences of role? There is a primary, then a secondary?
This was coming a bit from Matthew Lang and other work last year, or 2 years ago. Tarini, you were there in the process modeling that happened at IC Foods.
Yeah.
Right. So there was this notion that a process can have a primary and a secondary and a tertiary objective. That might have been stated in like some plan to carry out the process. Indeed, the pureed strained carrots is the primary objective of the straining process in this instance, or in any instance, a straining process primary objective is some strained food as output. I personally, I'm not so sure how useful defining this as a role is. One could have annotated that this is the primary output of the process. But this is a way of saying that it was meant to be the main thing. And therefore all of the other products, if they can be avoided or changed, they don't matter so much with respect to what somebody was carrying out.
Or they'd be secondary or something.
Sorry. But what about co-product? You have two outputs. You don't prioritize one versus another. You put the two on the same level.
Then by all means say so. Just say objective role instead of primary objective role, for example.
Yes.
So that creation of a little hierarchy of roles is up to us to ferret out what's useful. Perhaps this is a more even-handed way of looking at it, that some process may have two objective roles or more objective roles, and they're all equally valid and important. And then later on, for some particular interest, you might start reintroducing that actually something was primary and something was secondary. So here's an example: winemaking. Grapes come in, wine comes out, wine vinegar. Well, that's the secondary objective. We're not making all our money there, but we're making some money. So
yes, it's like yes, a valorization for co-product or waste.
Mm-hmm.
Just it's not the primary objective; it's a secondary objective. Okay.
That is a very convincing example.
Which example?
No, about the wine and the wine vinegar. It's very convincing example why you need primary and secondary.
Okay. Oh, on that note, and before we hand it over to Warren, there just might be a wine tasting workshop in Barcelona, November 10th to 12th. And it's a hackathon to create an ontology for wine out of by looking at existing ontologies. And the proposal is to actually have that result go into Foodon. So the moment I hear that that's a go, I will be sending that out to all of you, and hopefully we can all meet in Barcelona, inoculated and ready to return to civilization. Okay, over.
I actually had a small comment. This is Hande.
Okay.
I'm wondering if objective is more of an agent's perspective than a process. You know, the agent has the objective with this process, whereas the process has more of a function. I'm not really sure what the right vocabulary is.
Yeah, I think it's, I wouldn't say that it's the agent that has the objective. The agent may or may not have a brain, but the planned process carrying out a planned specification may have primary and secondary objectives defined for inputs and outputs that you would start using that language on. But I agree that, like, at one level, this is actually kind of like a secondary level of analysis. I would say that an objective role is probably at the primary level. This process will fail if we do not achieve this objective. But whether something's a waste or a primary objective, I think that's probably more a matter of interpretation as a result of whatever objectives were at work, and therefore could be laid on later or by inference, say.
Yeah, when we have roles like that, I think it makes for some of the applications that I worked on previously. I know that roles create a problem, so yeah, that's why it caught my attention. And then I don't know if this is the right vocabulary.
All right, tell you what, next month, let's talk about roles versus capabilities, because as well in Obo Foundry, there's been a move to talk about things in terms of capabilities rather than roles. I'm capable of being a doctor. No, I'm not, but say I was, and I'm on an airplane, they will call me, whether I have my doctor credentials or not. I'm going to help save a life. That's because I have the capability of being a doctor, pretend. And so we might start talking, instead of has role, we might say has capability, and that's way more important in certain circumstances.
And also function.
Mm-hmm.
That something has a function. I'm not saying we need all of this vocabulary, but it's just good to clarify.
Right. It's a very close partnership between function and capability. Function means it was evolutionary or intentionally designed to have that capability. Capabilities might exist by accident, but yeah. Okay,
I also think this with, like, just if anyone wants to whet their appetite for next month's call, it's about like functional foods, like food having a function. So if you're thinking more generically in the OB world about function, to think whether when you start talking about foods, all those definitions hold up and mean the same thing.
Okay, let's make it add it to the agenda to try to flesh out those distinctions.
Tarini, I challenge you to actually apply this to beer commercials and figure out the function of beer according to the commercials. I think it would be a hilarious paper.
Sounds fun, but I'm doing too many unfun things at the moment that I need to be committed to.
I remember a meeting, it was in biontologies on the ISMB, something like 10 years ago, when its first time was introduced, this function versus roles versus capabilities, and it was the most vicious discussion I ever attended in my entire research career.
Wow.
Just a bit of warning to you.
Oh, well.
People are taking it so personally.
Oh dear. Well, we will take a very
Just be a little bit more careful.
we will take a very peaceful and meditative approach to contemplation.
You look like very peaceful bunch of people. I still remember a person from Barry Smith's group introduced it for the first time. The person was attacked, literally.
Yeah, I met some personalities out there. I know what you're talking about. Okay, Warren, over to you.
So from our perspective, we're working on beer, which has, and it's existing processes or data that we get from existing processes. So from our perspective, a lot of this is instance driven as opposed to class driven. And we deal with bizarreness where sometimes you have a sensor, sometimes you have a person using a sensor, and sometimes the sensor is the person. So there's these bizarreness that we need to deal with in terms of a process. I'm just going to share my screen very quickly here. So for example, what we've been using for process has been really prov and activity and time. And the prov and time ontologies have a mapping that allows you to go from a materialized point in time to a relative measurement. So this particular representation is simply how you calculate adding cascade ops 20 minutes before you stop boiling. And the neat thing of this representation for us is that we can have a plan where all of the timing is relative to the process somewhere in time. And then we can materialize it as a clone or an instance as we actually record the making of the beer. The things that are a bit of an annoyance is that measurement and observation, everybody seems to have their own way of doing it. And I understand that we're studying here from OBO's perspective, the process generically, but the 98% problem that we're dealing with in inputs and outputs is moving something from container A to container B in this quantity in this time frame. So that is something that right now we handle with an extra activity, which is movement. But we can't just say, oh, we have an input of X from A to B because there's no measurement of quantity. And the quantity has a direct involvement or a direct result onto the quality of the product. With respect to actually what we're putting into it, we just simply use a qualified usage and we point to the entity of the product, but it's the entity of the product, not its class. And that allows us to deal with the specific container or specific repository of the ingredients going into the process. What you actually put into it, you'll need to go into 2 or 3 instances or classes down the line. We accept that because it's the only way to preserve traceability and identity at the same time. Again, this is a representation of how we do a measurement. And it's got 4 standards in here at the same time. It covers all the bases. It's unreadable by a human being. Fortunately, this is meant for a machine. I haven't integrated really OBO's views of measurement into here yet, but my hope is that at some point we'll just have an endpoint that speaks whatever variant you want for a measurement, and that's what you'll get based on your content negotiation. Because if we're selling it commercially, it has to be GS1. From a measurement perspective in terms of hardcore science, it'll be OBO or it'll be QUAT. And schema.org is the way to actually sell things on the web. So we're pulled in multiple directions concurrently, and we'll probably have software deal with the problem. But if we can actually try and reduce these amounts of standards, that would be a tremendous help.
Yeah.
Sorry. So again, from our perspective, the measurements, the reason I like SSN and SOSA is I can make a measurement or an observation. There's no real comment as to what the difference between the two is. But I can say that it's a measurement. I can say that it's a person's eyeball measurement of a container which they declare to be full. And then we can put an accuracy on that measurement because of human behavior. Or if it is actually a physical sensor, we can point at a description of that specific instance of that physical sensor and say it was 500 milliliters. So from our perspective, this fixes most of the problem in that we can simply say, this is where we hang everything, including the process of how we got that measurement, which may have been automated by somebody else. And we keep talking about this, but really there's 3 or 4 layers of process. Because if you say I'm going to boil something, really there's another control process that maintains that boiling temperature, or that maintains that state of boiling. And that in itself is additional modeling, which we may or may not decide depending on the context.
Yeah.
So, sorry, Damien, I keep interrupting. But from an operations perspective, Jessica has modeled a pale ale, and she's about at 3,000 lines of RDF to actually get it done.
Mm-hmm.
So we're talking about fairly complex information systems here.
Mm-hmm. Gotcha. Feedback, people? I have a few things, but others?
Yeah, I think it will be really important to test this proposed process ontology on such use cases. I didn't hear any obvious contradiction to what was discussed today, like, okay, you can just have several processes for boiling and maintaining boiling, or whatever else you need to introduce to cover that use case. Obviously, that use case will require a lot, but the very cause, the very essence of generic process ontology, it requires analysis, but my first impression is that it remains quite unchallenged by this use case. But this is something what important to check. Yes.
Well, again, the question here becomes how do people see the data? So for example, here I have gross weight and schema.weight. Gross weight is whatever it is without the packaging. Schema.weight says, oh, it's just weight, which has no context for us to work with, but they say it's weight. So, okay, it's weight. And thus, what becomes really critical is the specification of a lot of these identifiers, because you say, okay, it's the weight or it's the volume, and under what condition.
Mm-hmm. Okay, so indeed, so I've reviewed schema.org and GS1 for the use in USDA's FDC graph project, and have seen those trade-centric, just get it done and not define it a whole lot approaches. So I get that there's this need in the commercial world to use these, and they are de facto standards that are going to go through into the future. And then we've got the sort of pure science folks trying to think up the perfect solution and taking years to do so. So I get that tension. What I'm thinking is we will need a transform. We will need a transform that can go from a more pure process model and arrive at a schema.org or GS1 use of language for the same thing.
The irony, Damien, is that a lot of these things are defined precisely by somebody's legislation. Mm-hmm. And that's the bizarre thing, in that trade just says, use this, and it's horribly underspecified, but somewhere in some legal legislation piece, it's defined very precisely.
I see. Right.
And so that's why I like this idea of citations, because you say, if you say this is the alcohol by volume according to X, then we have a citation that's rooted in concrete somewhere.
Mm-hmm. Right, and I'm expecting that those will be variations that Foodon will need to reference as legislative specifics. Just one comment about the whole class versus instance thing. I'm expecting every bit of data in a database to be an instance, and maybe some of those instances are punned as class identifiers for some semantic reason. When I talk about classes, all I'm talking about is the definition of the language and their identifiers that gets implemented as instances in any specific process flow or, yeah.
I'm easygoing about that. So I'm willing to go with it.
Yeah, well, just I haven't done it yet in any of these examples, but usually I draw any of the class level terms above, and then I do a little dashed line, and then I construct sentences out of that vocabulary, and the relations are all instances as well. What we haven't really talked about in this group is the distinction between OWL, RDF, and graph, property graph databases. We can maybe touch on that in a month or two, just to prepare people for Neo4j representations, etc. Because OWL ontologies are great for defining the language, but it needs to get used in the real world. So how does that happen? Okay, this brings us to over an hour, and this is really great. I love it. Let's return with more next month. And what I welcome is people volunteering to work on particular little problems and models. So Robert, that's great to have your very specific beer stuff in, and I'll study your slide in more detail. So welcome other people bringing exact examples to the table. It strikes me that maybe the next example we really need to pick apart is boiling. That distinction between boiling as something that occurs without controls, and then boiling as a controlled process, which is this distinction between our processes that have a plan specification wrapped around them and that are occurring as a result of a device. So I will add that as my mission for a month from now, to add a more detailed boiling example.
And do you think it will be interesting to try to present how we could represent in with PO2 this process of doing carrot? I cannot pronounce.
Pureeing, yeah.
Puree de carotte.
Puree. Isn't it a French word? Come on.
I don't know how to spell it in English. So
okay. Right.
Puree.
It's puree, yeah.
Okay. Yeah. It will be interesting, or another kind of example than PO2.
Yeah. I know that you're focused on capturing information. So that would be, if it's not overwhelming to do in a month, I mean, in a few hours, then that would be welcome.
Who will try?
I will try to apply this generic schema that you presented today for our lab case. So if we can represent our main laboratory actions using the roles, participants, whatever, to do it in OBO correct fashion.
Yeah, if you could pick one or two, like boil or whatever, that would be great too.
Yes, because I know there is a lot of other researchers and also serious industry projects that are working with representation for robots, for automated labs. It would be interesting just to have this exercise to see how aligned it is. Of course, it is a secondary objective, not primary.
Oh, I have my eye on making this stuff be standardized enough that it can be the vocabulary used in industry.
Yes, that is the idea. That is why I want to do this exercise, to see if there are some serious problems or some gaps. I will try to do that.
Great. All right. Thank you, people. And I'll put up a copy of this video for anyone you want to pass it on to.
Bye.
Okay.
you. Bye.
Bye.